All right, so welcome to our free GRE prep hour for December 12th, 2021. I'm Dmitry, and I will be your host today. We are going to be talking about some speed strategies for quant today. So I did a separate video that should be available. If you're watching this recording, it should be available soon in YouTube also on general speed strategies, and we'll talk about that in a minute. But today we're going to try to apply some of our quant speed strategies to three particular areas: rates and work, some of these multiple identical worker robot machine kind of problems, some divisibility and factoring problems, and some problems around consecutives and stats, mean, median, total. So in general, the idea is that we're working with these ways of getting faster on the GRE. And I have to be careful. My point is not that you should be hurrying your way through the entire test. Often you want to be careful and take your time. And in fact, that in itself is a strategy. You know, the first thing I list here is front load your efforts. Put in some work so that you can understand the problem, so that you know what you're looking for. However, this is a time test. And a lot of people get stuck just spending way too long on a problem. So we want to know when to let a problem go. That's one way of getting faster. But we also want little things that we can do to make us more efficient, so we can feel like we can actually solve, you know, not maybe all, but most of the questions presented to us in the time allotted. Really important general principle with this test is it's more important to finish the test than to do a great job on any particular problem. So if you spend 8 minutes going in circles on question number 5, and that causes you to tank later in the test, that's just not a good investment of your time. Today, we'll be pulling some questions from our 5-pound book of GRE practice problems, available at finer booksellers everywhere. Definitely worth taking a look at if you are going to be at this for a while. So let's do a quick overview of the speed strategies that I presented in the other workshop that you can watch later. But basic idea is a few things. First off, you want to make sure that you are putting up enough effort up front to get something out of what you're doing. So that often means understanding the question, maybe writing a few things down, starting with some kind of estimate or gauge of what you're looking for in an answer, making sure at the beginning that this is something that's worth your time and that you can solve. You want to make predictions. And I think people underestimate how important this is. It's in verbal, it's everything, right? Big part of verbal is you want to basically know the answer before you look at the answer choices. With quant, you don't necessarily have to do that. In fact, sometimes it's lovely to work with the fact that it's a multiple choice test and say, I never have to actually calculate what the answer is. But we still want to have an idea. You know, if you're going to purchase something, a new car, airline tickets, a sweater, it helps to have an idea of what you're expecting to spend, right? And therefore you can be surprised. I wouldn't have thought a ticket from San Francisco to Albuquerque would be $17,000. Maybe I should look at another airline or another day. I could probably get a better deal. On quant, it's going to be more like, this answer isn't what I was expecting. I wonder if I've made an error. You're going to catch a lot of your mistakes that way. Sometimes you're also going to save yourself trouble because you'll say, oh, there's only one answer that makes any sense. So the flip side of that is you want to recognize a bad answer when you see it. Certainly part of that is being able to identify something that doesn't fit your prediction, like I'm saying, but it's also just seeing if there's an answer maybe that doesn't have something you predicted, but that can't be right for some reason. Oh, this number can't be negative, or it can't be a fraction, or it's got to be bigger or smaller than that. That's I think an important part of getting faster. In verbal, of course, it's also, hey, this answer doesn't make sense with what we're talking about, or this word doesn't fit this context. We're trying to avoid unneeded work, and I want to emphasize unneeded. I'm not saying just be lazy and just kind of say, oh, probably 5, right? We can be very precise when we're doing this, but we don't want to do more work than is needed, right? I sometimes say, if you were trying to figure out what restaurant to eat at, you don't have to do a lot of research on a restaurant if it's no longer in business. You're not going to eat there. It doesn't exist anymore. So you would hate to have done all this research into whether it's a great place to eat if you can't even go there. Right. And so similarly with quant, sometimes you might find that there's work you're doing that you just don't need to do to get the answer. And you want to think in terms of the whole section. We'll talk about that in a bit more detail in a moment. So a few things here. In terms of front loading, 2 things to keep in mind is you want to know what the question is asking in very clear terms. And if it doesn't make sense to you, this is a great place to guess and move on. You may also want to write down a solution expression. So for instance, if they say, what percent of the people on the team are left-handed? You might say, okay, so what percent? That's going to be left-handed over total is what percent? So you might say is question mark over 100 or something like that. So that's a solution expression or equation. In this case, it's an equation. Sometimes I don't have an equal sign. It's just like, hey, what's this over this? But that would be the idea. Prediction we talked about, but often this is something people think of as an alternative to solving, and it certainly can be. I could say, oh, it's got to be bigger than 10, less than 20, maybe B or C, but it can also be a way of catching our mistakes. And I predict constantly, even when I'm going to do a full algebraic solution. It's just a really valuable thing to be able to do if you can do it quickly. And so that flows right into recognizing bad answers. The better you're doing at estimating, at sensing what's reasonable, the more often you could just say, oh, well, not that and not that. Okay. Then you want to learn some topic specific things. So we'll talk about some specific areas today. It's not a test that you can just go off with general gut feeling for everything. You do have to know some specific quant content. We'll talk about that today. We also want to be able to do some quick eliminations in quant comp. I have a whole separate video on quantitative comparison strategies. We're not going to get deep into that today, but it's little things. For instance, if we know our quantitative comparison answers, we know they go A, B, C, D. Are this familiar? Right? You're going to have two quantities, quantity A and quantity B, and you're basically saying, is quantity A always bigger? That's A. Is quantity B always bigger? That's B. Are they always equal? That's C. Or can it vary? And often you're going to cut something pretty early. If the things are known quantities, right? The number of prime factors of 2,740 versus, the number of prime factors of 883 or something like that. Well, you may not know the answer off the top of your head, but there is one. So it's not D, and you'd cut D immediately. Other times, you're able to see immediately that there's more than one possible answer, but you can get one possibility. So let's say I test some numbers and I get that A is equal to 10 and B is equal to 3. Well, in that case, I can get rid of the two answers that don't fit this. I can say, well, I was able to make A 10 and B 3, so it's not that B is always bigger, and it's not that they're always the same. And anytime I can get a single case, I can narrow it down to either it's always that case or it's D. So I can get a 50-50 right away. And that's really important to make your life easier. And this will come back to our broad whole section strategy in a moment. Another thing we want to do is we want to not force ourselves to do more calculations than needed. So there are plenty of cases where you just don't need to do the precise calculation. You don't need to do it out to get an answer. And if you find yourself doing a whole lot of math, you might question whether you're doing the most efficient strategy. But you do have a calculator available. So if you need to crunch the numbers, you don't want to spend a minute estimating something that you could punch into your calculator in 5-10 seconds, right? So, use a calculator when that's the most efficient thing to do. There will be some cases where we're proving, like I said, maybe I've got a quant comp and I know the answer isn't D because I know there is a value, prove it. Other times I might have to test different values. And then in terms of the whole section strategy, the basic idea is we want to make sure that we're not worrying about this question or that question, we're worrying about the overall exam. And at no point is it important that I get this question right, that question right. Instead, I just want to do well overall. So first off, I want to know some benchmarks. How far into the test should I be at what times? And I'll give you a blog link you can use to get a better feel for that. Make sure that means you're guessing aggressively. That doesn't mean that you have to constantly guess, that you can never be precise, but it does mean that you shouldn't expect to do all the questions correctly. That would be a very unusual thing. If you're maxing out the quant section, that might happen, but for most of us, it doesn't happen. Last time I took the GRE, I did max out the quant section, and I still had 1 or 2 cases where I'm like, A then, right? There's still some of that. The other beautiful thing about guessing is that on the GRE, unlike some other tests, unlike, for instance, the GMAT, if I guess on number 3, and at the end of the section, I have time left, I can go back and change it if I want to. So I think of guessing as like putting something in a box or in storage. I'm not saying I never want this again and I'm going to throw it away. What I'm saying is I don't want this in my face right now. And so the same thing when you guess on a question. You say, all right, I'm going to guess on number 3. And if at the end I have time, then great, no harm, no foul. However, if at the end I don't have time, then I'm very glad that I guessed on that question because otherwise I would have run out of time. And often the questions where we're tempted to spend the most times are the hardest questions where we're not getting them right anyway. So it's not wise to spend, say 4 or 5 minutes on a question, right? The average time needs to be under 2. And so anytime you go much over that, you're really cramping the rest of your section. It's not worth it. Each question within the section is worth the same, whether it's the easiest question in the section or the hardest question in the section, their value is the same. Okay. So know your personal skip cues. Sometimes that's very specific things. You're like, hey, I don't know how to do probability, so I'd skip all of those. Or I know basic probability, but nothing harder than that. So I skip when it looks complicated. Sometimes it's long, wordy things that take me a long time to process. Some people skip the entire data interpretation section with the charts, and they just guess on those. And then if they have time at the end, they do them, but they know they get swamped in those. Other times it's just it's a more specific cue for that context of like, I've been at this problem for a minute and I'm not on the path to a solution. Okay, get out. So know when you're going to bail on a problem. When is it too late? And the same thing people say with, say, investing. What's your exit strategy? When are you going to sell this thing? Is there a point this stock could rise to where you're going to sell it? Is there a point it could drop to where you're going to get out and take your losses? And so I think we want to think the same way when we're doing a problem. You may have to adjust your strategy for section 2. As you may know, this test is adaptive, which means that you're going to have a particular difficulty of your first section. And then depending on how you do, you might be given a harder section, a medium section, or an easier section. And there's some overlap between these. So let's say I do really well in the first section, I get a hard section, and then I have a lot of trouble in that hard section. And let's say someone else does only okay on the first section and gets into a more medium section, but they do really well on that medium section. They might score where I'm scoring or a little bit better, right? Now, if you max out both sections, then you're going to be, way up here and no one can catch you, right? And similarly, if you tank both sections, that's going to, of course, be trouble. But there's room to redeem yourself to move, from one section to another or to get in trouble. So the main adjustment you want to think about is, do I tend to see a harder or easier second section? If I have trouble with the math and the first section is often a little hard, then I need to know that, and I'm really going to choose my battles to try to catch the ones I can get. Then it may be, at least for now, that my second section is easier. Then I might expect to get more right, and I might be more perfectionist about it and skip fewer questions. On the other hand, if you tend to do really well in the first section, you might get a really hard second section, and then you might have to choose more of your battles there and be more ready to drop things because time gets tighter. I'll have people who like, oh, I always have time left on the first section, and I'm always out of time in the second. So I want to think about that. How can I adjust for that? Make sure you're leaving time to get to the fill-ins late in the section. The way this works is early in the section, you're going to have those quantitative comparisons that are just multiple choice out of 4. So even if you guess randomly, you have a 25% chance. And if you're able to narrow it down in one of the ways I described, now you have a 1 out of 3 or a 1 out of 2 chance. So do you want to spend 5 minutes to get that better? Not really. Sometimes you want to move on. However, later in the section, and I think this is by design, there will be questions where it's a fill-in. And we'll talk ways to mess with those fill-ins. It doesn't have to be you know it or you don't. But to some extent it is, right? If they ask for a number and the answer is 249, what are the chances you're just going to guess 249? Very low. And so that really punishes people to work their time well, because if you're trying to guess at the end, good luck. Whereas earlier in the test, when there's more multiple choice, it's easier to guess. There's still multiple choice near the end, but some of them are fill-ins. Something to be aware of. Make sure you have a plan for the data interpretation section. As I mentioned, some people skip it. Some people just have to really watch their time. Some people find that there is, one part that's going to be too hard for them and they need to let go. Some people make a plan always to skip it first, and then they're leaving time for it, but they're going to leave a more limited range of time. So just have a plan of how you're going to handle it, depending on your strengths of this. Some people find that it's not any harder than anything else, and they can put it right into the rest of the section and just do it in order. If you want to check out our blog, you can see there's a 3-part post all about timing and includes some recommended timing benchmarks. So for those of you who are attending live rather than watching this recording, I'm going to put this link into the chat right now so that you can pull that up. And you can read through all our advice on timing. Okay. So any questions on any of this stuff, concerns, thoughts before we move and do some questions? Sure. Someone was asking, do you mind going over the A, B, C, D logic again? Let's do a quick example. Again, I have a whole video just about quant comp strategy, so I won't do all of it because you can check that out. But let's do the brief idea of it. So I'm just going to cover this up. So the idea in quant comp is if I have two quantities, A and B, and what I'm trying to figure out is, do I know which one's bigger? Right? Sometimes one of them will just be a number, like 5. And then it'll be something like, I don't know, Reggie's required time to complete the assignment or something like that. Okay, and then they've given you some information up top about what that time is. Okay. Sometimes, right, so they've given us something about Reggie, right? So the answer choices will say A, B, C, D. Is it A is always bigger? I can't write Reggie. Or B is always bigger, or they're always equal, or it can vary. So in some cases, you might say, if the initial info clearly leads to one answer, we can cut D immediately. Do we see why? So if they say something like, Reggie is going to be doing, this many words per hour for, this many hours, or sorry, for this long of a task, right? You can just divide. Okay, here's how many words she needs to write. And don't you like that Reggie's a girl? Why not? Okay, this is how many words she needs to write. And here's how fast she writes. So there's her time. I might not be able to calculate it easily, but I know there is an answer. And so I would cut D. Okay. Other times there might be variation, right? So what if I had something like this? And they say something like X equals Y squared. And I say, well, what's bigger, X or Y? Well, it depends, doesn't it? So give me a case. What's one possible value for X and Y? If X equals Y squared, what can X and Y be? Just one possibility. Sure, I could say, hey, what if Y is 2, X is 4? So if X is 4 and Y is 2, well, X wins this time. Doesn't necessarily mean X wins every time, but it wins this time. So what answers does that immediately allow me to eliminate out of my A, B, C, D? Again, A, B, and C stand for A is always bigger, B is always bigger, or they're always equal. And D stands for depends. Okay. So which answers could I immediately eliminate if A was bigger this time? Well, I know that if A was bigger this time, B isn't always bigger, right? B isn't always bigger because it wasn't bigger now. Okay. We want to be careful of generalizations, right? If my daughter and I arm wrestle and I win, does that mean that men always beat women in arm wrestling? Nope. It means I beat my kid. I beat my kid. It sounds terrible. You know what I mean? I won the match against my kid. Sorry. But you couldn't make a gender generalization, right? It was that one time. But in this case, I could say, all right, X is bigger than Y this time. I get rid of B. Okay. And I can't say they're always equal because they weren't equal this time. So the generalization is, hey, if I get a result, I could cut the two that say the other results always happen. And this is a general thing I can say. Whenever I have A, B, C, D, if I get a particular result, then I know it's not always something else, right? If I won, she doesn't always win. If she wins, I don't always win. We don't always tie either. And then we'd have to see, does it vary? If tomorrow we wrestle and she wins, okay, then it's D. You don't always know who's going to win just by who it is. So here I could put in literally, infinite number of possibilities and get a different answer. If I just keep putting in y is 3, y is 4, y is 5, I'll keep getting that a is bigger. But what if I put in something weird, like y is 1 and x is 1? Oh, well, then they're the same. I've already crossed off C, so it's not C, it's D. But I've already narrowed it down to 2, and then I just look for cases. I actively try to knock out the remaining case. I could also have made y is 0 or a fraction, and in any of those cases, x would not have been bigger anymore. Okay, that help? Awesome. Okay, let's try some other content here. So like I said, we're going to try a few different areas, see how far we can get. So we'll start with some rates and work problems. Sorry, it's not rates and work. So we'll start with some divisibility problems. So let me give you, change my mind again, rates and work. I'm fickle. See what you could do with this. I cover some thinking like this also in my lesson on fractions, parts, and wholes. But see what you can do with this. You don't have to try to do it a super fast way. We're going to work on doing it a super fast way, but do whatever you think you can on this. And if you get an answer, go ahead and pull that answer in. So I'm going to launch a poll here. All right, take a moment to try this out. Okay, if you don't have an answer yet, go ahead and put in a guess. May not have given you enough time, but just want to get an idea of this. If you're watching this as a recording, you always can pause, but we want to think about how we can be time efficient. So I'm seeing a variety of answers here. If I were going to teach this as like an algebra lesson, then I would say, all right, well, let's work out how much the 9 machines do in 4 minutes. And then I try to get that down to a rate for one machine. How fast does each machine go in terms of jerseys per minute? And then I'll just look at what the task is that needs to be done and divide that task by the rate. And I can do a whole table with it, right? And this is what we get into in our book for sure. But there's another thing I can do, which is to start with an estimate. So if I know that 9 machines do 27 jerseys in 4 minutes, what do I know about this new job in terms of the time? What can I see about this new job that's going to help me figure out the time required? Any ideas? And I might sort of just jot some of this down on my scratch paper. So I might say, okay, 9 machines. I can do a table, right? And I've often done that. 9 machines, 27 jerseys. Okay, that's going to be 4 minutes. So I look at what I have here. I want to have 4 machines, and I want to have 60 jerseys, and I want how many minutes? And so I can front load partly just by writing this down and being clear. So look at these adjustments that I've had to make. What effect are those going to have on the time? What effect will those things have? What if we held the machines the same and we just doubled or increased these jerseys from 27 to 60? It's about double. Could we say, look, what if I wrote this? What if I had 9 machines, but I want to do 60 jerseys? What would I know about that time? Same workers, same speed. What's going to happen to the time? When I've got about double the work, it's probably take about double the time, right? So I know it's right away greater than 8 minutes. And so my reasoning there is that I've got more than twice the work, so more than twice the time, all else being equal, right? If I can read, a certain book overnight, well, how long would I need to read a double length book? Well, twice the time, all else being equal. Plus it has a lot of pictures, right? So right away I can say, well, even with 9 machines, I would need more than 8 minutes to make 60 jerseys, so I can cut 8, right? It's going to be more than that for sure. I haven't even got to the 4 machines part. What effect should it have when I go from having 9 machines to 4 machines? Is that going to make the time lower or higher? I have to be careful, because if it would make the time lower, then maybe I was right. I would have been right to pick 8 after all. But 4 machines is also going to make us slower, right? So we're going to have fewer than half the workers, right? So it's going to take more than twice the time. Do we see that? Just like if I were doing something totally different, like how long will it take me to save up the down payment for a house? Well, what if I get cut from full-time to part-time and my hours are less than half what they used to be? Oh, well, bummer. Then if I can save it all, it's going to take me more than twice as long to save up that money, right? Sometimes things like that are non-linear. Like maybe if I got my hours cut, I just wouldn't be saving any money. I'd be spending all my money on rent. All right. But assuming that it was all extra, I don't know, I'm living with my mom and dad and I get to keep all the money or something, right? Then it would still take me more than twice as long. So we can say, oh, well, I had more than 8 and then more than double of that. So my answer needs to be 4 minutes times more than 2 times more than 2 again. So it's going to have to be more than 16. It's some number that's more than 8. And then double that and then some. It's going to be more than 16. Do we all see that? So I can immediately cross off B and C, and I have to pick out of D and E. At this point, I can just kind of guess. I could say, well, maybe 18 is more than 16, so that's good. Or hey, I'm doing more than 8 and then doubling to more than 16. That's 2 more thans. Maybe 20 is safer. At that point, it's a bit of a guess, and that's okay. That might be as far as I can get. That might have taken me 2 minutes already, and I need to get out of there, in which case it would be the smartest thing to pick one of those and get out. However, if I'm able to do that fairly quickly at the beginning, maybe I'm doing some of that in my head. I'm not telling everyone to skip writing stuff down, on the contrary. But if I'm able to do some of that in my head, I might have still some bandwidth left to do it more precisely. And so if I wanted, I could quantify it exactly. I could say, well, I start with a base of 4 minutes, but I have about twice as much work. Well, how much exactly? Well, it's going from 27 to 60. That's going to take 60 over 27 as long. I can just throw those numbers in there, right? Think about it if I had like a nice even number, like 30 and 60. 60 will take twice as long as 30. So what will this take now? 60, 27, so a little more than twice. Similarly, I'm going from 4 machines to 9, but I'm not going to take less time. That's where estimation is valuable, because I might do this wrong if I don't think about what makes sense. I could easily see someone putting 4 9ths here. In fact, I think I've done it and I wrote this problem. So I know when to put 4 9ths, because wait a second, it shouldn't take less time. It should take more. It takes 9/4. If I had started with 8 machines and went to 4, I would be going half as fast. So I'd go twice as long. Here I'm going to be 4 9ths as fast. So I'll take 9/4 as long. So I have this situation where I'm multiplying 4 times 60 27s times 9/4, and I can actually just go through and do the cancellations. 4 cancels with 4. And then 9 cancels with 27 and leaves 3. 60 over 3 is 20. Okay, so this last part might have looked like a bit of, maybe it's just not how you think about these things. And again, I get into that bit more in my parts and wholes lesson. But I think it's also being able to do both parts or just one, right? I'm being able to choose. I might start by just estimating something, and then I might do some more algebraic version, or I might estimate and just let it go with that, just estimate and move on. Or I might estimate and then try to quantify that estimate more precisely. You know, it would be like if I would try to figure out the combined height of everyone in the world. Well, there's like 7 billion people. Well, I'm 6 feet tall, but I think I'm on the tall side. Oh yeah, well, some people are kids. Definitely I'm on the tall side. Okay, let's say the average person is, I don't want to do 4. Let's just say everyone's 5 feet. That might be a little high, but okay, 7 billion times 5, that's 35 billion. So roughly everyone in the world together is 35 billion feet tall. It's not precise. And then if I wanted to get more precise, I could look at what % of the people in the world are, different ages and genders. And, I could try to add more quantity to it to get it more precise. But I don't always have to do that to get an answer. Okay, let's try another problem that involves rates. Similar kind of reasoning that you can do, slightly different setup. Give this a try. All right, so take a moment to put in a guess at this point, if you haven't already put something in. It's a good habit to get into because we do want to kind of work on our ability to move on, and we want to work on our ability to guess. We want to work on our ability to notice answers that make more or less sense. So we've got a lot of information here, these identical servers and adding servers and server work rate and all these things. What if we simplified for a moment and simply said, how much longer, all else equal, how many times longer should 216K take than 9.6K? How could I estimate that? I don't, I can do a calculator for sure, and you might want to do exactly that. But assuming I'm not using a calculator for the moment, how could I estimate that? What if I make these numbers a little simpler, right? what if I said 210? How many times longer should that take? Right? If I wanted to get 10 things done and then someone said, no, not 10, 200, how many more times would that take? How many times longer? I would just divide, right? So it should take about 20 times as long if I ignore all this bit about the number of servers, right? If I just say I'm going from a job of 9.6 thousand, right, 9,600 to 216,000, it's about this. Yes, you could do it on your calculator, right? This is the one part I'll pull up phone during class because sometimes it's annoying to pull it up on your desktop, although you can certainly do that. On the test, obviously, you will not have your phone, but you can do 216 divided by 9.6 and get an exact answer. And the exact answer is 22.5, but it's still about 20, right? So now what's happening to the server, right? If I go from 4 servers to 6, what should happen to my time, right? Should my answer be more or less than 20? Well, from a lot of your answers, I'm figuring you're thinking less, right? If I go from 4 servers to 6, I'm faster, so less time, right? How much faster? We can really do this with the numbers. We can just say 6/4 as fast. We're dividing by the 4 servers to find the rate for 1 and multiplying by 6 servers to find the rate for 6. So how much time, not how much less time, but how much time for 6 as much time. And 4/6 is the same as 2/3, right? So we'll want to take that roughly 20 number and take about 2/3 of it. I know 2/3 of 21 is 14. So somewhere around there, a lot of you chose A, 15. If you want to quantify it exactly, we can say, hey, I want 216 over 9.6 times 6/4, or again, 3/2. Sorry, 2/3. Don't do it the wrong way, see? We already figured out on the calculator that this is 22.5. So I could rewrite this then as 45/3, which is exactly 15, which some of you got. Cool. So if you didn't get this one right, that's fine. There's lots of ways to get in trouble on this one. But you want to look, was my answer reasonable? Did it make sense for the number to be in the teens or in the 20s based on the information that I have? Could I have gotten a rough idea? For instance, are there any answers I could have gotten rid of in, say, 30 seconds or less? And then sometimes it's useful to do that, even if we're going to do the whole problem out algebraically. Okay. So some specific things here for speed, thinking about adjustments to rate and work problems. Hey, when I have more workers, it takes less time. When I have fewer workers, it takes more time, and I can use reciprocals to figure that out. If I have, 7/5 as many workers as you do, then all else being equal, I'll take 5/7 as long. We can do that kind of quick manipulation, but we can also use those things to estimate and just get an idea, right? If you know how much it costs to, I don't know, get a small marketing brochure translated into 3 languages, then you might get an idea of how much it would take to translate a large manual into 12 languages, right? Okay, it's 4 times as many languages and, this many times more pages, and maybe it's not linear, maybe you get a discount or whatever, but it still gets you an idea, right? And if you couldn't afford to do the first task, then, I really can't afford to do the second task, right? It gives you some ideas. Okay. Let's flip content here, touch on a couple things more. So I mentioned divisibility. I want to try something in that. So this one I won't give you time to just want to look at it. So this one's something different. It says P is divisible by 7 and Q is divisible by 6. PQ must have at least how many factors greater than 1? Okay. So if we want to do this, we can say, all right, well, PQ is going to have everything that P and Q have. So 7 and 6 have nothing in common. So I could say, all right, well, PQ needs to, PQ needs to be a multiple of 7 times 6, which is 42. And you can study all this in depth, right? For instance, if I had 9 and 6, it wouldn't work that way because 9 and 6 have a factor in common. I'd have to think about that. But here I could say it's 42. So they will need all the factors of 42. So of course I can sit there and do it, right? I can say, okay, what are my factors of 42? Okay, I'm gonna have 1 and 42 and 2 and 21, and I can keep going, right? But let's think about what we know right away. If I make this table, is the number of factors here going to be even or odd? If I write out all these factors, because I might make a mistake, I might forget something, I might be wrong in some way, I might do my multiplication or division wrong. But if I have 1 and 42 and 2 and 21 and 3 and something like this, I'm gonna have an even number of factors. And in fact, every number that isn't a perfect square, like 100 or 49 or something like that, every other number will have an even number of factors. Perfect squares will have an odd. But they're saying factor is greater than 1. So I might write immediately that I'm going to cross this factor off. So I could actually know the table will have an even number of factors. Cutting 1, our answer is odd. And then I could look at what's left in my answers. Okay, well, it's not 6. It's not 8. I already know it's not 1. There's several different answers, right? So it's 3 or 7. And so if I get past 3, which I have right now, I can stop. So do we see what I've done? I've said, all right, how many numbers go into 42? Because I need this. I know 1 gives us a 7 and the other gives us a 6. And I know that I'm counting everything but 1. So let me identify that at the beginning so I don't accidentally forget and count 1. Really easy to do that kind of thing. Then I'll just start counting. But if I see that I'm past a certain point, then I can stop. I say, hey, 42, 2, 3, 21, 40, that's already more than 4. It's like what I was saying about affordability. If you already know that one part of what you want is out of your price range, then forget the rest, right? If you want to go on some vacation, you realize, oh my gosh, the airfare alone is more than I can afford. Well, then you don't need to look at hotels, because unless the hotels cost negative money, unfortunately, you're going to have to wait on that vacation. So we can use that to our advantage. Sure, we can do it all out. We can say, okay, 3 and 14, and okay, 4 doesn't go in, 5 doesn't go in, 6 of course goes in because we know 6, and there's my 7. Okay, there are my 7 factors, but I don't have to write all those out to get there. Okay, questions on that? Let's do another variation. Here's another one where they're asking us for maybe a little bit more work than might seem necessary. How many factors greater than 1 do 120, 210, and 270 have in common? So again, I might think about doing some counting. But here, since it's a list of things, I can't automatically say, oh, I know that the number should be odd or even or anything like that. Can anyone see a way to cut one or more of these answers? Can you find any numbers that go into all these lists? All these numbers? They're all divisible by 30. Oh, okay. So, all are multiples of 30. And we're talking about all factors, so not prime factors. We got to slow down and make sure we're catching those things, right? But we don't want to include 1. So I might start by just factoring 30. Okay, 30 has 1 and 30, and 2 and 15, and 3 and 10. 4 doesn't go in, 5 does. Look, 30 by itself, if I don't count 1, has, what is that? 7 factors, just like the last number. Cut, cut, cut. If you had to guess at this point, what would you say? Do you think those are all the factors they have? Or do you think there could be 30 factors that these numbers have in common? While you're thinking about that, we can look at the other way we might do this, which is just to factor one of the numbers. Let's factor 120. Takes a bit of work. 1 and 120, 2 and 60, 3, I'll just divide 120 by 3 is 40, 4 and 30, 5, to divide by 5, I divide by 10 and double it. So a tenth of 120 is 12, so this will be 24. To get 6, I can say, ooh, if 3 goes in 40 times, 6 will go in half as many times. So it's going to be 6 and 20. 7 doesn't go in. 8, yeah, that goes in half as many times as 4 does. Let's see, 9 doesn't go in. 90 and then 30, 10 and 12. And now look, I'm running out because the next number will be 12, and I've just done that. So this is the whole list. So I could now see which of these are in 210 and 270 if I hadn't done the other approach. But I can see also that there's nowhere near 30 factors in this entire number. And so one way we might get rid of E is it's giant. It's way more factors than I think any of these numbers have. So we've got to stick with D, and we don't have to do all the work. Okay. Any thoughts on that one? Questions? Okay. Speaking of speed, let's see if we can speed through a couple more things here. I'll give you a quant comp version. And so one thing you'll think about in terms of speed is benchmarking off of quantity B. Quantity B can be something to compare to and say, hey, what do I know about this? But it can also be a clue about what we might be looking for in an answer. So I'm going to give you some time to try this one on your own. Pull this in when you're ready. All right, so let's use that second quantity. I know I didn't give you a lot of time, but let's use that second quantity as a clue. They're saying that we want to compare to 0. And so they're asking, basically, it's a way to ask sort of a yes/no question, or at least can you answer this yes/no question? Is the smallest number in the set positive, negative, right? Or you could see it as a 3-way question. Is it positive, negative, or 0? But you basically could say, is it more than 0? So is the smallest number positive? So I might not have a lot of great shortcuts for adding these up, and that's one thing I want to work on. But what if I just tested the smallest case I can think of where it's positive? What if I made the numbers 1 through 15? Does anyone know how to sum those up without doing it? 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10. I could do that. Anyone know a faster way? The formula we can do, the sum is equal to the average times the number of terms. What's beautiful about consecutive integers is we often know the number of terms already, and the average is nice and formulaic to find. So the average will be the average of the ends. And the number of terms you can, when we're not given a clear number, here we know it's 15. If we're not given that, we can do last minus first plus 1. So 15 minus 1 is 14, and you add 1 back in to count the first number, and you get 15. But I don't need a formula to find how many numbers are in this set of 15 numbers. I don't need a formula. But if they ask me for like 246 to 803, then I would just say, hey, 803 minus 246, and then add 1 to actually count number 246, and that's how many numbers there would be. So I can then say, okay, the average of the ends, well, that's 1 plus 15 divided by 2. And that's how consecutives work, because they're going to be in order, one each, they keep growing by 1. So the largest number and the smallest number will be equidistant from the middle, which is the average. This is just something that you can learn and memorize. So I end up with basically something that says, okay, 16 times 15 divided by 2 And I could just do this out. I can know that's 8 times 15. 8 times 10 is 80. And then half that would be 8 times 5 is 40. So 80 plus 40 is 120. So you might say, well, okay, great. Now I know that the sum of the first 15 numbers is 120. So what? What does that tell me about the least number in my set? They only add up to 90. Oh, if they're going to be consecutives, I've got to dip below 0. I can't have them all be positive. Honestly, I suppose I could check to see if they're all even, could be 0. But then I would just take away the 15 and I would have still 105. So I know that my least number is negative and B wins. It has to be. And there's only one answer, right? We can get rid of D right away, because if I make the numbers bigger or smaller, the total will shift. There's only be one set of numbers in a row that adds up to 90. If I shift them one more to the right, they'll get bigger. If I shift them one more to the left, they'll get smaller. So there's only one answer, but it has to clearly be then that B is bigger now, because the smallest one has to be negative. The actual answer is -1 if you do it out. You could see -1, 0, 1, all the way up, to what that would be 13. These will cancel each other out. And you'll just have to sum the numbers from 2 to 13. We could say, okay, that's 12 numbers left. The average will be the average of those two ends. There's 12 numbers from 2 to 13. That's 13 minus 2 plus 1. And so I could then say, okay, this is 6. 15 times 6 is 90. That's my answer. So I could do all that out, but I don't have to. Okay, the number will always be negative. So what is my overall point with this? My overall point is that we can often use that quantity as a clue, something to benchmark off of and try, can I make it bigger than 0? Can I make it less? Here we saw that we can't make it bigger than 0. But it was also a warning. If we didn't even think about negatives, this is a warning to say, hey, think about them. They're asking if it's bigger than 0. If we assume that it's positive, then we won't think about that at all, right? It's just like if I assume anything, if I'm talking about a city, and then one of the clues you get is it's in the United States, you have to go, oh, before that, I didn't know that. Maybe I was assuming it was in the United States, right? Now, here, they're not saying it is 0. They're saying, is it more than 0 or not? You have to ask about that, right? So if you've been only thinking of US cities, and if I said, oh, the continent where this city is located, and you go, oh, I don't even know what continent we're on. Oh my gosh, I have to broaden my reach. And so that's important to catch our own assumptions as we work. Okay. Let's wrap with one more question in a related format. So this is again going to be about consecutives and averages. However, a couple twists. One is the numbers are much bigger. Instead of the total being 90, so the numbers are small, the average is 88. So the average now is pretty close to the total less set. The other wrinkle is this is a fill in the blank. I can't just work multiple choice in this. I can't guess. I just have to see what I can do. So I'd have to think about, is there a way other than just doing all the algebra for this, which we can talk about, but is there a way to get an idea? So if I know the average is 88, when I have a set, if I didn't know they were consecutive, I could say, well, okay, so if I get rid of that, 15 integers, the average is 88. What's the greatest? I don't know. The greatest could be 88. Maybe they're all 88. I could have a set like this, 88, 88, 88, 88, etc. The average could be 88. Just like, let's say everyone in our group here has 2 eyes, right? I hope you all do. It's, if you don't, that's cool too, but it's nice having 2 eyes, right? But if our average is 2, that could be because we all have 2, right? In fact, if our average is 2, we probably definitely all have 2 because, who has more than 2, right? To have that average. But when we have consecutives, we know it goes in order, right? It doesn't have to start with 1, but it might be 80, 81, 82, 83, or it might be, 1, 2, 3, 4, 5, all the way up to something, right? We don't know, but we know that they're going up by 1 each time. there can be consecutive multiples, so they could say like consecutive multiples of 5, so you're counting by 5s or 10s or what have you. But here, if they say consecutive integers, that means they're counting by 1s. So what we know is we have 15 values, et cetera, et cetera, et cetera, right? This one in the middle is going to be the mean. Why can I know that? Because with consecutives, the middle number is going to be the average. It's kind of a beautiful thing. And it gets back to what we were doing before. When we did, adding up 1 from 15, we could say, all right, if the smallest number is 1 and the largest is 15, the average of those two numbers is 8. That's the middle number. Well, we have something similar going on here, right? If I've got 1, 2, 3, 4, 5, 6, 7 numbers below 88, and 1, 2, 3, 4, 5, 6, 7 numbers above 88, I'm going to have 1 less, 2 less, 3 less, 4 less, 1 more, 2 more, 3 more, 4 more. They'll balance out. So rather than write all these out, I could say 89, 90, 91. I could just say, oh, wait, there's 7 more numbers. This one's going to be 7 bigger, right? So this will be, I could write it 89, 90, 91, 92, etc. I could do that, but if I just recognize, oh, 88's in the middle and I'm jumping up by 7, then I could jump straight to my answer, save myself a lot of time. In general, also with these fill-ins, I can look for ways to narrow it down. So I might say, hey, I know my answer has to be bigger than 88 because 88's the average. What's sort of the range I'm dealing with? Could it be 100? Well, let's see, if the biggest number were 100, right? Let's say we're just trying stuff out. If the biggest number were 100, the smallest number would be what, 14 less than that? Because there's 15 in a row, so 14 less. That would be like 86. That would put 88 way over here. So I know my number is more than 88, but it's a fair amount less than 100. So it puts me in a pretty tight range of somewhere in the 90s. So then it's more like multiple choice. I could test, well, what about 94? What about this, right? I could get an idea. I could also use the idea of even and odd if I could see that I'm taking an even and adding an odd, although at that point I might just have the answer, but that might show me that the answer is odd. So what I'm trying to do as much as possible is use what I know about the particular content of that problem to narrow things down, to get rid of answers that don't make sense, see what's likely or unlikely. But I'm also using estimation more regularly than people might think to sort of see where I expect something to land, where I expect something to be. Right. And I think that's very important. The same thing happens in science, right? They might test out a bunch of chemicals to see if some of them might work as good chemotherapy medications, or they might scan the night sky to see if there are certain kinds of objects in far off in space. But often they know somewhat what they're looking for or where to look. Not always, but often. And that allows us to save ourselves a lot of time and trouble. Hey, what are some things that aren't going to be effective chemotherapy drugs? What traits does a successful one have to have? Where should I not point if I want to see this? And especially when I have a small set of possible numbers here, very narrow range compared to all the chemicals in the world or all of the universe, right? I have a very limited scope. Even on a fill-in, there's only so many possible answers. And I can use that expectation to shape how I do my work. So just some ideas for you. I'll try to, if these are helpful, if people say that they enjoy doing these speed strategies, then I'll put some more recordings of these types together for future sessions. Of course, also, if you want to check out any of our classes, love to see you. Our first session's free, so you can check out the class and see what to make of it, and make sure you're gel with the instructor and all that before signing up. So happy to see you around. I'm going to stop there, but stick around if you have questions for me. Other than that, best of luck with your studies and hope it all goes really well. Thanks, everybody.